All right, only a few weeks late, but finally we're going to go through the first solution for the inaugural fortnightly code problems. So this is kind of the first time you're watching this. Basically, the idea is going to take problems from daily coding problems, and we've got a fortnight for everyone in the team to kind of have a crack at it. And then I've given myself the laborious task of going through the solution and sharing that. But hey, what a small price to pay. So to kick off, we've got a little problem here called well, it's got no name, but we can call it the swapping linked list node problem. And what does it want us to do? Well, it says given the head of a singly linked list, swap every 2 nodes and return its head. For example, given 1, 2, 3, 4, return 2, 1, 4, 3. Now, if you've never come across like linked list before, you're probably going like, what the hell is a linked list? What is this like notation of 1 arrow, 2 arrow, 3? And so it's probably worth just like, for those who haven't seen, a linked list or what the hell I'm even talking about, we can kind of just jump in, define that, and then go from there. All right, so I've defined this class here called LL node, meaning standing for linked list node. But before we kind of jump into that, let's kind of think about why would we even need a linked list node, right? Hey, we've got arrays. Why do we need another type of array? So let's say we have nums, right? And we say that's 1 and 2. Now that's simple to us, but when it comes to actually when the virtual machine, right, when the JavaScript VM sees that, it goes, oh, okay, sweet, you've got an array here of numbers, and let's say numbers are 4 bytes, no, let's say they're 8 bytes, right? Let's say they're 64 bits on a 64-bit machine. So the JavaScript says, oh, sweet, I need to put 1 and 2 in an array. I'm going to ask operating system for 8 plus 8 bytes, right? So I'm going to ask operating system for 16 bytes. And then some time passes, right? And we say nums.push, and we push on 3. Well, in our head, we just think that just happens, atomically. Just put 3 on the end. But what actually happens is that JavaScript has to say, do we have enough space in nums to just add on 3 at the end? And in this case, it says, well, no, I only asked 16 bytes, and now I need another 8 bytes to store 3. So it has to ask the operating system, hey, can you give me an extra 8 bytes at the end, starting at the end of the memory segment to back this array. And in a lot of cases, the operating system can't give you that, right? Because it says, well, sorry, some other process or some other call in this current process has already kind of taken that memory, right? It's occupied. So instead, it has to give you back just a fresh chunk that you have to then like write your previous data, right? So in this case, you get a fresh chunk for 24 bytes. And what happens is the VM then has to go and actually copy over 1 and 2 into this new array. So kind of under the hood, it's creating a new temporary array and then like copying all the elements over, right? So this is kind of the problem. Now, this kind of problem's solved a little bit in the sense, or kind of helped in the sense that generally the pattern here is that every time you ask for a new chunk of memory, you double the capacity. So here you ask, for 2 elements, then you would ask for enough to solve for 4, then 8 and 16, and this doubling kind of means that if you kind of amortize, if you kind of average out the cost over that whole sequence, it gets it back down to something that's a bit more constant time. That's happening in the sense we think of nums.push.3 as constant, in the sense that you just go to the end and add it, right? But in reality, it's a bit more complicated than that. But besides the point, that's kind of the problem here with an array. So a linked list really is just a kind of a way of saying, well, can we not pay the price? Can we have adding to an array, to a list in constant time without having to do this kind of doubling thing, right? And we can. So what a linked list says is that instead of storing all your elements contiguously in memory, you actually just store each value separately, right? You ask the VM, hey, I want a chunk of memory to store this element, right? So in this case, we store 1 separately, and then we have a pointer that points to the next element. Now, in JavaScript, pointers are kind of hidden away, but you can kind of think as a reference to the element. So, okay, so that kind of gives us a feel for why the hell we would even need linked lists, or rather, linked lists in general. Now, when we're dealing with linked lists, generally at a high level, there's two types, right? There's singly linked and doubly linked. Singly linked just means I just have a pointer to the next element in the list, and doubly linked list just means I've got a pointer both ways, right? So I've got a previous and I've got a next, or rather previous and next, but you get the point. So here we're creating a singly linked list. So we're just going to grab a value, good old value, and next, right? That's kind of to construct. So a list, right, is nothing more than just, this is actually quite interesting, because why do you call this a linked list node and not have another class called linked list? And the reason here is you can think of a linked list as just whatever is pointing to a node is a linked list. That will kind of become clearer in a sec. But we can say this dot value is value, and this dot next equals next, and we're just going to default that to null, and we're good to go. So we can kind of think of before, if we wanted to store 1, 2, 3, 4, we might say, well, I have nums 1, 2, 3, 4. But to store nums in this in the linked list version, alright, so v2, I'd have to say new LL node, and then the value is 1, and then point that to another node, the value is 2, and you can kind of see the pattern here, and then 3, and then new LL node 4, and then finally null, and then close them all up. Alright, those two, both of these kind of data structures store the values 1, 2, 3, 4. But they have different characteristics, right? And that's the whole point of data structures, is that each data structure has a different set of characteristics or properties that are associated with it. And in this case, we can add to this linked list without having to need to if we run out of memory, to run out of space for, say, the array, we don't have to kind of copy over. We can just in place add a new element, and we can always do that. Okay, that's great. But this is a little bit, what's the word? It's cumbersome to have to kind of, explicitly spell out. So it'd be kind of a lot nicer if we had, a little utility called, like, say, lno.from, and we could say 1, 2, 3, 4, and it under the hood goes and does this, calls the lno constructors for us. And we can say we're using this here for the test cases. So let's just quickly define that, right? So we're going to have a static called from, and it takes in an array, and let's just say values. We know it's an array of values. Okay, let's just call it array. And what are we going to do? Well, easy enough, right? We're just going to say, okay, well, I'll grab the first. Well, no, here, generate a note from the array. Yeah, I'll grab the first out, and I'll get the rest, right? And basically, all I want to say is, hey, I want to construct a new node with first, and then I want to call rest.from. I'll just make a little typo there. Rest.from, or rather, llnode.from rest. And another case here is that if the array is the array.length system equal to 0, return null, right? Null is the empty list. Sweet. So that's good, right? So generally that's kind of, you might want to define, usually it's pretty helpful to have like a utility that you can convert from an array to a linked list. the other utility, it's nice to go from like a linked list to some kind of string representation, right? Because again, when we're testing it, it'd be really nice if I can just say it needs to be 2 and 1, representing it as a string, describing it as a string as opposed to having to go and do this list.node from. So let's just do that. So let's define a method called toString. And what are we going to do? So we're going to say, we're going to grab value and next out of this. And we're going to say, we're going to have a string, right, which is just going to start off as the value. So just for context, what we're doing is we're just going to try and find a way, we're going to define a function called toString that you give it a linked list and it gives you back the string representation of it. So in other words, what we're going to do here is we're going to say, we expect, if I said 1 new node 2 null, right, toString, if I called list that, list.toString, that should equal 1, 2. That's what we're going for. Okay, sweet. So look, so we start with if the string's a value, or rather, if the first thing I want to do is we want to grab the value out and put that in the string. Then we say, well, if we don't have a next, right? That means if next is null, then that means we don't have a next function, or rather a next node. So then we can just return the string. But if we do, that means we want to add the arrow, right? So we say, actually what we want to do is we want the string, and then we want an arrow, and then we want next.toString. Right, we want to know we want to take the string, from this point onwards and just add on the arrow at the start. Sweet. So now, if you look at our test cases, that's not that. Jump. Let's say node cam, and it says L or node. I've got no idea what you're talking about, and that's fair enough. I'd just say new. And sweet, so it's ran the first test case, which was we expect L node, a single node with 1 to equal 1, that passed, so run the next one. So 1, 2, they should be swapped, so we expect 2, 1, we get 1, 2. So that looks like it's working great. So this is kind of part of the process, right? It's, before you kind of work out, we haven't actually implemented a solution here, right? So we would expect, call that test or input maybe. So we expect swap nodes input. Yeah, input, but maybe expect swap nodes to string. Sweet. So our job, right, is implement swap nodes. So we get a list here, a linked list, and so given a linked list, swap every second node. That's kind of what we're doing here. So we've got everything's in place, right? We've defined the data structure, right? L node. We've got some test cases set up, and we've defined the function that's going to actually implement the algorithm. So okay, we're looking good. This is kind of what we want. Now we've got to kind of turn our thoughts into how would we actually implement swap nodes. So what I've done is sometimes it helps to kind of step back and go through the example, right? And sometimes going through the example helps. Sometimes you can kind of see maybe there's something there that kind of, the solution kind of reveals itself a little bit, right? You kind of can pull the curtains back a little bit and get a little peek into the solution. Or at the same time, at least you might get a sense on how you should do the naive solution. So let me just clear this. So here's how we can represent a linked list, right? So we can think of these circles as, a node, right? Which has a value, in this case 1, and a pointer to the next node. And we have head. So I briefly said, like, what is this head? Well, if I had something like const list equals new node or 1 and then null, right? We know that this is the list just 1, right? Or maybe I'll just chuck in, I'll add one more element just because it's a bit lonely. So we know that that's the list 1, 2. So if you think about a list, here, the actual name, right? The name list is the head of the list. I can pass that to another function, and that's a reference to the first element in the list, right? It's an element to this node here. So head is really just a pointer, right? It points to the first element in the list. And so when you kind of call a function with a linked list, whatever that node that you passed it to the function refers to, you can think of as the head, right? Because it's kind of pointing to the first thing in the list. So we kind of want to, we really want is we want to run some process, right? We want some, hey, you can join that Zoom meeting if you want. It'd be great if we had something like this where at the end 2 and 1 was swapped and 4 and 3 was swapped, and our head now points to the new, from the list. So that's kind of what we're heading for. So I'm just going to move that out of the way. All right. So one of the nice things about a linked list is that basically this is kind of what we can actually do is we can just move through every second item, right? When we iterate, because you think about how would you iterate over this thing, where you would just say, all right, start here, current equals the first node, and then at the end of the loop, we would say, all right, current now equals the current node dot next, and we would move through by just looking at the next pointer. But we can actually just move to every second node by just, instead of moving along by dot next, we can move along by dot next dot next. So we can kind of ask the next element for each next, and that can become the current, right? So we can kind of move like straight to 3 as opposed to going via 2. And that way, every node will swap, right? We don't have to do this check. We just know that if we're looking at the node, that means it needs to be swapped. So we think about it, 1 by itself, right? If we just had 1, we wouldn't swap it, right? So you can't just blindly try and swap it. There's some of a condition, right? And that condition is we can only swap 1 if it has, a next node, right? So if it's 1, 2, we can swap. If it's 1, 2, 3, we can swap, right? But notice how if it was 1, 2, 3, right? If we didn't have 4, we couldn't swap 3, right? So there's this kind of property here that in order to swap, we've got to have the node in front of us. And it kind of makes sense. How can you swap with the node in front of you if you don't have a next node? So that was good. So it kind of seems like while we have a node in front of us, right, and we're moving every second node, we'll do a swap. So what does this swap operation look like? Well, we can kind of think of swap like this, right? We can say, well, I have current and I have current next, and what I'm going to do is you can kind of think of it like this, right? The current dot next points to the next node. So we're going to take current and current next, and we're going to basically just swap their values. So we'll say, okay, sweet, 1, 2. So we look at current, right? So we set the loop, we look at current, and we say, all right, what is the value of current dot next? So that's 2, and we can kind of think there will be somewhere we'll have like a temp variable that just keeps track of what was in 2. But we can think of it like this: we take 2 and we take the other one and we swap their values. Right now we swap their values. That kind of feels like, well, that kind of looks like right. So if you kind of look at that solution, we need to have 2 at the head, the front of the list, which we have, and 2 points to 1, and now we just need 1 to point to 4, but right now it points to 3. So let's kind of go to the next step of the iteration, right? Which means that we kind of make current now equals current dot next, which now the pointers will look like this. So current now points to 3 instead of pointing to 2. And then we can do the same thing, right? 3 has, the next node is 4, and so we can do the swap. And so the same thing, we just say 4, we say 3. And voila. So it looks like it could be as simple as just iterating through every second node of the list, swap their values. So that kind of feels right, but I'm not sure. But let's have a look. Let's jump in. Enough of this whimsical business. Let's just jump in and have a look. So I'm going to comment that out. So we kind of said, well, let's say const head equals list, right? So this is the head, right? This is the pointing to the first value of this, and you can even think of it like, grab the head, as that's what you're going to pass this. So what we're going to say is we're going to define a variable called current, which just points to the head, and our condition was that while current, right? Because if I pass through an empty list, I shouldn't swap any nodes, right? So if I say swap nodes of null, null's a valid list, it's the empty list. So in that case, we don't want to iterate at all. So this should just return back null. Sweet, so while we have current, and we said while current.next. Alright, so this is important, right? We only want to look at the node, we only want to do this swap thing, if the current node has a next node. So let's have a look. Okay, sweet. So looking back here, we kind of see, all right, we want to do a swap. So we said to do the swap, we said, well, all we need to do is we need some temp, right, that grabs current.next.value. And we know we can look into current.next.value because this condition above was true, so we know current.next has a value. And then we're going to say current.value equals temp, and then no, we're going to say current.next.value equals current.value. All right, so that's we give the next node the value of this node, and then we say, okay, current.value equals temp, and then we just have to return the head, and we're done. So let's just see if that works. Didn't like actual. Swap nodes, input. So we're getting a infinite, so it's cursing infinitely, it's never stopping that end of the list. So why would that be? We're not actually moving, we're not moving along at all. So we need to move current to be current.next.next. And I think that's it, right? So done. You beauty. So if we look at the solution from Fortnightly Coding Problems, we can see here under, 145 sol.py. So yes, it's in Python, but I mean, we can kind of see it's doing pretty much the exact same thing. Swap every 2 as a function. It first defines a variable called current and assigns it to the node, right? So this would be head in our case. And then basically while current and current next, right? Go through and swap the values and then increment current by next. So I'll leave it there and see you in 2 weeks. Ciao.